In this video, we're going to talk about displaying quantitative data, and we're going to focus first on dot plots. Let's just jump right in and talk about what a dot plot is. It's literally what its name suggests. It is a bunch of dots plotted on a number line. So let's take a look at an example. Let's say that we counted up the number of goals scored in 20 games played by the 2016 U.S. women's soccer team. So what we have here is our data, and we've got 1 goal, that is our lowest number, and 10, that is our highest number. So what we're going to do is we make a number line. We put the title down here as goals scored, and for every 1 goal, we put a dot. So 1, 2, 3, 4, 5, 6, etc. So we would do that for all of the data points. And we would leave the 0, 6, 7, 8 blank because there weren't those values. So here are the steps to making a dot plot. They look just like the other kinds of data visualization tools that we've talked about. You draw and label the axis. Pretty self-explanatory. You scale the axis. We know all about scaling. And then you plot the values. So they're dots and you just stack them one on top of each other. So let's give this example a try. It's called Give It Some Gas. So the Environmental Protection Agency, or the EPA, is in charge of determining and reporting fuel economy ratings for cars. In order to estimate that fuel economy, the EPA has to perform tests on several vehicles that have the same make, model, and year. So what they did is they took a sample of 25 2018 Toyota 4Runners, and they found that this was the fuel economy rating for those 25. So let's do 2 things. Let's make a dot plot, and then let's evaluate the fact that Toyota reports the highway gas mileage of its 2018 4Runners is 22 miles per gallon. Let's see if this data gives the EPA sufficient reason to investigate that claim. So in order to answer that question, we've got to make a dot plot first. So remember the 3 steps here. Draw and label the axis, scale the axis, and then plot the values. So the easiest way that I find to do this by hand is to do it on graph or grid paper. Makes your life a little bit easier. So what I've done is I've kind of taken a snippet of a little bit of graph paper and I've drawn a thicker black line there. So I've drawn our axis. So I need to label the axis here, which I've also done. I've called it highway fuel economy rating because that's what we're talking about. That's what those numbers or data points represent. So my next step is to scale the axis. So this set of data is not in numerical order. So I went through and I found the lowest value, which is 21.5, and the highest value, which is 23.3. So that means that I'm going to find the difference between those things and I'm going to scale the axis. So let me show you how I do that. All right, disclaimer, you've heard me say this before, but my handwriting on at least my iPad looks like hot garbage, so apologies. Hopefully you can read it. Something that I like to do to figure out how many little dashes or gaps that I need on my dot plot is to take the largest value and subtract the lowest value. So 23.3 minus 21.5 is 1.8. So, and it looks like everything is by 1 decimal point. So that means that I need 18 little notches. So I just started at 21.5, and to round it out to 23.5, it's a little bit more than 18, but I'll be able to plot every single one of these dots without having to cram them in. So we've drawn and labeled the axis, we've scaled the axis, so now let's plot the values. So there's no rhyme or reason as to how you plot these data points. You can do them in order, or you can just go straight down the list. Something I highly recommend, especially if you've got a lot of data points and a lot of literal dots to make, as you cross them off as you go. So here is our dot plot. So now we can attempt to answer the second part of this example. So full disclosure, I took a screen grab of the book's dot plot, so you don't have to look at my hand-drawn one any longer. And so what Toyota reports is that their highway gas mileage for their 2018 4Runners is 22 miles per gallon. Now, we have to figure out, does that data give the EPA sufficient reason to investigate that claim? So remember, the EPA took 25 random 2018 4Runners and tested its highway gas mileage, and here's the data. right? So if 22 miles per gallon is what Toyota reports, there's only 3 that fall at and below 22 miles per gallon. And pretty much 23 out of those 25 that the EPA picked were above 22 miles per gallon. So I would say no. 23 out of the 25 cars tested had an estimated highway fuel economy of 22 miles per gallon or greater. So I would say that they would bump up that rating. Now, as you can imagine, dot plots can take many different forms, and their shapes can vary widely. So let's now talk about describing the shape of a dot plot or any type of data visualization. So there are 2 major camps that I like to think of. So your dot plot, for example, can be symmetric or it's going to be skewed. So let's talk about those 2 things. If your dot plot is roughly symmetric, it might look something like this, where the bulk of your values are pretty much in the middle, and then it tapers off to the left and to the right. So it creates kind of a symmetry, right, in the middle. So it's kind of a mirror image on both sides. It doesn't have to be exact, so that's why we say it's roughly symmetric. And then when we talk about skewed graphs, or graphs that are not roughly symmetric, they're either skewed to the right or skewed to the left, because those are the only 2 directions we really have. Something that I'd like you to keep in mind when you look at these, which you might be thinking, all right, wait, this is skewed to the right? The bulk of the data points are on the left. And this is skewed to the left? The bulk of the data points are on the right-hand side. The reason it's called skewed to the right and skewed to the left is not where the bulk of the data lies. It's in what we call its tail. So think about the tail of an animal, right? It's pretty slender usually. The tail is this end where there are fewer data points, and the tail over here is this end. So the tail is skewed to the right, and this tail is skewed to the left. I know, just remember skewed is backwards to what you think. And now you may be asking, well, what about dot plots that aren't skewed or roughly symmetric? What do we call those? Well, great question. There are a lot of different graphs depending on the amount of data that you have to display. So for example, when you have something that has one single peak, right, where a lot of your data points are at one point, that could be skewed. We call a single peak unimodal. And as you can guess, if you have 2 peaks, like in this example, we call that bimodal. And when there's more than 2 clear peaks, that's called multimodal. So we would say that this graph, for example, has 2 distinct clusters, right here and right here, and it has 2 clear peaks, making it bimodal. So the idea that we're building towards is that there are a lot of ways and a lot of words where you can describe distributions of your data. So that's like what your graph looks like. So you're always going to be looking at the overall pattern and what we call clear departures from that pattern. So there are 4 major things that we look for when we want to describe a distribution or what's happening with a graph. So we look at its shape, its center, its variability, and any outliers. Sometimes, also, variability is sometimes referred to as spread, which is a little bit different than the range, but it's a spread. And then the biggest thing that I would say as a takeaway of this slide is that there's this cute little saying called statistical opinions can vary. And that is how we remember shape, outliers, center, and variability. So statistical opinions can vary. True statement. So let's take a look at that example that we were working with earlier, the 20 games played by the 2016 U.S. Women's soccer team and the number of goals scored in those 20 games. So remember, our data looked like this, where our highest peak over here is at 1, and then it kind of went down a little bit. It went up a little bit more at 5, and then we've got these 2 dots over here at 9 and 10. So when we first look at shape, we would say the distribution of goals scored is skewed to the right. Remember the tail is at the right-hand side, with a single peak at 1, and then there's a gap between 5 and 9. So there's no goals scored here. When we talk about outliers, we would say the games when the team scored 9 and 10 goals appear to be outliers, right? It's all the way out here at the tail. The center, we would say the median, so that's the middle number, is 2 goals scored. So one way that you can find the median or the center is to line up all the numbers, or you can count the number of dots and figure out, all right, what's half of 20, 10, where's that number? And that's going to be in our 2 goals scored. And then variability, we're going to say the data vary from 1 to 10 goals scored, so the lowest number to the highest number. So let's work through an example together where we can compare the distributions of, for example, household size, or the number of people living in a household, in the United Kingdom versus South Africa. So our problem is, how do the numbers of people living in households in the UK and South Africa compare? So this great resource called Census at School, they have a random data selector. They chose 50 students from each country, the UK and South Africa. And so here are the dot plots of the household sizes reported by the survey respondents. So let's compare the distributions of household size for these 2 countries. The first thing we're going to look at is shape. So remember that we've got symmetric and we've got skewed to the left and to the right. So when I look at South Africa here, the tail is over here, and there's definitely a big outlier over here. So I would say that this is skewed to the right. And then the UK looks roughly symmetric. There's not enough data points over here on the left to say that it's skewed. So here's how we would more formally describe the shape. So for South Africa, I would say it's skewed to the right with a single peak at 4, up here, 4 people, and a gap between 15 and 26 people. So that tells us about the shape. And then for the UK, it's roughly symmetric with a single peak at 4 people. So notice that we either described it as symmetric or skewed, and then we talked about the peak and then any gaps that there are. So next up is outliers, and what I notice over here already about South Africa, there's definitely one at 26 and also at 15. But for the UK, there's really no tail, right? So there's not really any outliers. So here's what we would formally say. For South Africa, there are 2 outliers at 15 and 26 people, and the UK, again, no outliers. So next up is center, and another word to describe center is the median, so the middle number. Where's the center of our data? So what I do to figure that out is I know that there are 50 respondents in each country, UK and South Africa. Cut that in half, you get 25. So you can either count from the left or from the right. I'm looking for the 25th dot in a row. So here, the 25th dot is 6 people in a household for South Africa. And for the UK, the 25th dot is under 4 people in a household. So we would sum that up and say that the median in South Africa is 6 people, while the median in the UK is 4. So we could say that household sizes for students in South Africa tend to be larger than for students in the UK. So the last thing to describe is variability, or the spread, so the lowest value to the highest value. And so in South Africa, it's pretty big variability, at least compared to the UK. So the smallest is 3, the largest household size is 26, but in the UK it's much smaller, so that's from 2 to 6. And of course, more formally, we would just say South Africa, the variability is from 3 to 26 people in a household, and the UK is 2 to 6 people in a household. So the household sizes for South African students vary more than for the UK students, at least in this data set. All right, that's going to do it for this video. Thank you so much for watching.